The cellular respiration. What is the cellular respiration? It is the metabolic reaction occur in the cell of the organism to convert the chemical energy and nutrients into adenosine triphosphate, or we know as ATP, and release the waste product. First reaction, glycolysis. It occurs in the cytoplasm of the cell. It divided into two phases. First, energy investment phase, and second, energy harvesting phase. Energy investment phase. First, 2-ATP used to rearrange 6 carbon compound into unstable sugar. It will attach to 2 phosphates from the ATP. And now it split into 3 carbon compounds. Energy harvesting phase. Now the 3 carbon compounds will be oxidized, or we can say that it lost its electron. And now 2NAD+ regains those electrons to make 2NADH, and 2NAD+ will bring the 2 phosphates to attach to the 3 carbon compounds. And now next step, the 4 phosphates will be donating into 4 ADP. It will get and it will create 4 ATP. And now what we have left is 2 pyruvates, or it is 3 carbon compounds. The result. First input, we put in glucose, 2 NAD+, 2 ATP, 4 ADP, and 4 phosphates. And output that we get, 2 NADH, 2 ADP, 4 ATP, and 2 pyruvates.
Preparatory reaction. Preparatory reaction is the second step in cellular respiration, next from glycolysis. Preparatory, also called pyruvate oxidation. Preparatory is happening in the matrix of mitochondria. As the picture shown in the right side below. The input that used for this process is pyruvate, which are the products that get from the first step or glycolysis. We also get 2 pyruvate from it. By the way, the glycolysis is happening in the cytoplasm. When it finishes the process, it will enter to mitochondria to continue the step after. At first, the 2 pyruvate, which are 3 carbon compound, is lost electron and turned into acetyl-CoA. 2NAD+ is gained the electron to become 2NADH. 3 carbon compound lost electron, so it now 2 carbon compound. One of it will get out from mitochondria and get out from our body as carbon dioxide. Then it becomes acetyl-CoA, which are 2 carbon compound, and it attached to coenzyme A for input and output. The input is 2 pyruvate, which we get from glycolysis, 2NAD+, and 2 coenzyme A. For the output is 2NADH, 2CO2, which released out from our body, and 2 acetyl-CoA. In preparatory reaction, there are no ATP gain, but there are 2 NADH that it will go to electron transport chain to use for making ATP. Also that there are 2 CO2 that will release or go out from the process and get out from our body.
Next step is Krebs cycle. It is the third step in the cellular respiration. It happens in the matrix of the mitochondria. And this cycle will use only one acetyl at a time, so to produce one glucose it needs 2 rounds of the Krebs cycle to produce. For the first step, the acetyl-CoA or 2-carbon compound will attack to a 4-carbon compound, and it will form a 6-carbon compound. Step 2. It will oxidize to 5-carbon compound by NAD+, and it will release NADH and CO2. In step 3, it will same as the step 2, but it will oxidize to 4-carbon compound by NAD+ again, and it will release NADH and also the CO2. Step 4. 4-carbon compound will rearrange itself to oxidize ADP to ATP. Step 5. 4-carbon compound will also rearrange it again, and it will transfer 2 hydrogen atom to FAD, and the FAD will release to FADH2. Step 6. 4-carbon compound will rearrange and also oxidize by NAD+, and it will release to NADH. Step 7. The result from step 6 will become the first 4-carbon compound again that will go to the acetyl-CoA in the step 1 to make the next round of the cycle. So the conclusion of the Krebs cycle, I will show you the input and output. So this information I already include for the 2 rounds for the Krebs cycle already. For the input, it will include 2 acetyl-CoA, 2 4-carbon compound, 6 NAD+, 2 ADP, and 2 FAD. And the output I also include it for 2 rounds. It have 2 ATP, 6 NADH, 2 FADH2, and 4 CO2.
The electron transport chain is the fourth step of cellular respiration. It happens in the crystal membrane of the mitochondria. The goal of electron transport chain is to couple energy stored in electron acceptor to a proton gradient that drives ATP synthesis. The electron transport chain has 2 main processes with each electron transport chain is where electron get shuffled from one complex to other, and the other process is ATP synthesis or chemiosmosis. It will pump the proton gradient to generate ATP. The process of electron transport chain. The first one, the NADH from mother cycle will oxidize or lose electron to NAD+, and the FADH from mother cycle will oxidize and lose electron to FAD. Both electrons of each hydrogen from NADH and FADH are lost to electron transport chain, and the hydrogen become the hydrogen ion. The high energy electron from NADH and FADH2 will pass through the electron transport chain as they release energy along the way. The next step The energy from the electron transfer will pump to the proton from matrix of mitochondria across to cascade membrane of mitochondria from low concentration to high concentration, forming an electrochemical gradient in the intermembrane space. The next step is the high energy electron will pass through. It will release the energy to pump hydrogen ion until the electron transport chain. It is the place where low energy electron leave and go to the oxygen. The next step is the oxygen is the large electron acceptor. It accepts low energy electron from the chain, combined with the hydrogen ion in the matrix of mitochondria to form the water, which is one of the products of cellular respiration. The next step is chemiosmosis or ATP synthesis. The first step is the electron chemical gradient will produced by the build-up of hydrogen ion in the intermembrane space now has a large amount of potential energy ready to be released. The second one, the hydrogen ion will move down to the concentration gradient into the matrix through ATP synthesis by using the channel protein. The next step is the hydrogen ion will move through the channel. The kinetic energy they provide help ATP synthase to add a phosphate to ADP to form high electron. For the result, the input of this process is NADH, FADH2 and oxygen, and for the output is ATP and H2O or water.
Next is anaerobic respiration. What is fermentation? It's a metabolic process in anaerobic respiration which an organism will convert carbohydrate into acid or alcohol. Or it is a process that converts organic food into a simple compounds and chemical energy, for example, in bacteria or yeast. This picture below shows the example of the fermentation cycle. And this is more information. The fermentation cycle, it produces 2 ATP, it don't need oxygen for the cycle, and the last acceptor is the pyruvate.
How many types and what are those? There are two types of fermentation, which are alcoholic fermentation and lactic fermentation. First type is alcoholic fermentation, which known as ethanol fermentation. It's an aerobic pathway used by yeast to break down glucose into ethanol and carbon dioxide. It produces ethanol and carbon dioxide. Only some microorganisms which can pass through this type of fermentation. By this process, it's why that the bread has hole. When we make the bread, we need yeast in the process so it produces bubble or hole for the carbon dioxide gas inside the bread. Ethanol is also produced, but while eating bread is not intoxicate. It's because that the process is take short time. Most of it will evaporate during the process. For lactic acid fermentation, it produces lactic acid and happen in the mast hole. Most of the organisms can do this type of fermentation. This type will be used when need loss of energy in fast situation. For example, when we do hard exercise and our body get hard time to get oxygen, it will use this type by the way.
What are the differences between cellular respiration and fermentation? The biggest difference that we can see that it is oxygen. Cellular respiration uses oxygen in its reaction, but fermentation it occurs in the anaerobic, so it doesn't need oxygen. And the cellular respiration produces more ATP than the fermentation because it's lack of oxygen, so the sugar molecule does not break down completely.